Okay, we'll start this video where we left off with the second derivative of, or the derivative of the first derivative, but still in terms of y prime. So what we need to do for this is to swap out the y prime with the original, with the value that is of the original derivative. And since the first derivative is 9 plus 8y over 5 minus 8x, I need to swap out y prime and put that in. And so this is where we were. And it made it was very reasonable, I should say, to cancel out the 5 minus 8x factor in the first term of that. I haven't put the denominator in yet. And that is fine to do it that way. Normally we would do it that way. But again, this is a game, and what we're trying to do is we're trying to match our answer to one of the given answers. And one of them, you can see, has the 5 minus 8x quantity cubed. And the way that we could get that answer then is to, instead of canceling the 5 minus 8x factor on the left term, it's to add a denominator of 5 minus 8x to the term on the right of the numerator. And so we would multiply top and bottom of the right term in the numerator by 5 minus 8x, and now that would give me a factor of 5 minus 8x that I can now move into the denominator, where the denominator is now 5 minus 8x cubed. And you notice that my numerator really is the same thing, both terms. It's just double that. So we'll make that into 16. Again, it would seem very reasonable to cancel out the 5 minus 8x term in the numerator with 1 in the denominator, and it would leave us a pretty simple expression. However, the story doesn't end there. And so again, trying to match what they have, what we're going to do is to expand out the numerator. And when we do that, that is multiplying, foiling out, quote unquote, the two binomials, the two binomial factors in the numerator, we would get 16 times the quantity, 45 plus 40y minus 72x minus 64xy. Now what you're going to see here is not something that I would ever expect you to do on a test. But again, it's a game. It's a mathematical game. You're trying to see if you can work things to fit. And so there is some value in that, although I would never require that on a test. And so what we want to do is to go back to our original equation. We're trying to somehow swap things out. No matter what we do in that numerator, things are not going to cancel out. We have x terms, y terms, xy terms, we have constant terms, etc. They're not just going to cancel themselves out. So one thing that we might do, though, is to go back to the original equation and to somehow look for something there that we can swap out. And when we do look there, we see something that might be of some interest, and that is that we have in the middle of our expression in the bottom, we have this plus 40y minus 72x. And if I were to rewrite that by factoring out a negative 8 and rearranging the terms, I would get 40y minus 72x is equal to negative 8 times the quantity 9x minus 5y, which we can then see in the numerator is really the same as negative 8 times the quantity negative 2xy. So I got rid of all that stuff in the numerator, and I'm left with negative 8 times 2 quantity 2 minus 8xy. So going back to my original expression, I'm going to take out the 40y minus 72x and replace that with negative 8 times the quantity 2 minus 8xy, which leaves that looking something like this. So sorry, that plus 8 should be a minus 8. I think that's correct. And what we're going to get when we multiply that middle part out, and sorry, that minus 64y at the end should be minus 64xy. And then you will see that the 64xy's go away. 45 minus 16 is 29, and 16 times 29 leaves you 464. And the final expression is, or the final result is 464 over the quantity 5 minus 8x cubed. And again, this is not something that I would ever expect on a test, but it is a good algebra game, quiz, whatever, for you to try to figure out and to match their answers. So the answer is definitely B.